All right, here we go. Unit 3, Lesson 14 notes. Now, these notes are all about horizontal stretching and compressing. So it wouldn't be a bad idea to write that at the top of your notes so you know what we're talking about here. Now, this video is definitely going to be a good test of how good you are at pausing and hitting play, because I'm going to go through a lot of information. When I tell you to pause, the more you take advantage of pausing and trying it on your own first before you go on and see what I put as the answer, the better you're going to understand this material. So I really encourage you to have your finger over that pause button and be ready to pause and try something on your own, and then go on and check the work based on what I have. Okay, so we're going to graph three functions here, this f of x, g of x, and h of x. Right here are the x values I want you to fill in to your table. I chose these x values because I know that for those functions, these are going to give me pretty good results. There's no specific reason that you have to choose any x values. We're just choosing some x values that we can plug in, and then we get some y values, so we can get some x and y coordinates, some points, and we can plot them and see what our function looks like. So right now, go ahead and pause and try to fill in the row here for f of x in the table, or the column here for f of x. Fill that in, and when you come back, I'll have the answers and we'll go through them. Okay, so f of x is square root of x, so square root of -4, undefined. Square root of -1, undefined. Square root of 0, 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. So that's where I got those. That's hopefully you're seeing right now why I chose numbers such as 1, 4, and 9 as my x values. Now over here is my graph. It's a little stretched compared to yours. It's just zoomed in on the first quadrant. But I went ahead and I plotted my points like 1, 1, 4, 2, 9, 3, and drew my graph for f of x. Now, it's definitely beneficial to kind of follow along with what I'm doing. So if you have multiple colors, or you can get a blue pen and a red pen to kind of follow along so your graphs are different colors, that would be fantastic. Now what we're going to do is we're going to do g of x, and we're going to plot it on the same coordinate plane. So g of x is square root of 2 times x. So how we're going to get that? We're going to plug in the x values. So here we're going to plug in -4 and do square root of 2 times -4, so on and so forth. Now's the time that you should pause it and try to fill in this column on your own, and then graph g of x over here. I'm going to do it in red. So go ahead, if you have red and you want to match with what I'm doing, go ahead and do that. Pause it now, and I'll have the answers when you come back. Okay, there's g of x, and how we got that, plugged in -4, so it was square root of 2 times -4, or square root of -8. This one became square root of -2, both of those square roots undefined. Square root of 2 times 0, square root of 2 times 1, or square root of 2. This one became square root of 8, and square root of 18. So I'm just plugging all these x values right into this formula up here to get y values. And then I went ahead and I plotted my graph there. Now, what I want you to do is put a few points on your graph. Now, these aren't points that you found from the chart, but these are definitely points on the graph here. I've got these points on the red graph there, and I want to compare them to the points on the black graph. So our black graph is square root of x, our red graph is square root of 2x. And if we look at these points here, what we notice is when I compare straight across, just the x value changes. It's like this point right here that my mouse is over at 9.3 is now over here at 4.53. This point here that was at 4.2, it's now over here at 2.2. This point here that you can't see the coordinates, but it was 1.1, it's now at 0.51. So what happened was the x values were multiplied by 1/2. So when I put in the 2, I multiplied x by 2 in the equation, it ended up multiplying the x values of the points by 1/2. Huh, that's interesting. It didn't multiply them by 2, it multiplied it by 1/2. So this stretch is a little a little strange because when we were doing vertical stretches and we would like multiply by 2, we would just stretch every y value by 2. Here, when we're doing horizontal stretches and we multiply by 2, we actually multiply the x values by 1/2. So you can see here that the points are horizontally compressed. They're multiplied by 1/2. All right, let's go ahead and fill out this last row or column in our table. So for each, to fill each one in, take the x value, so -4, and plug it into the equation, and then evaluate it. So go ahead and pause now and fill that in, and then come back and check your work with mine. Okay, so when I plug in -4 into there, it becomes square root of -4. So square root of 4, and I get 2. Okay. Sorry, quick interruption, I'm back. Anyway, so when we plug in -4, it's -4, which is +4, and then square root of that is 2, -1, which is 1, square root of that is 1, and so on. And so that gives us this graph, which hopefully you've graphed the blue line. And if you compare that to the black line, what happened? We took the black function here, and we flipped it over the y-axis in order to get the blue function. So from this, we're going to get our rules here for the graph of f of a of x. So f of a of x, this is when we put a multiple, a number in there multiplied by x. So like here in G, we did square root of 2x, so a is 2. Here in H, we did square root of -x, so a is -1. So the rules are right here. So if we noticed in G, if we remember what you wrote down, it was horizontally compressed by a factor of 1/2. So right down here, the function gets horizontally compressed by a factor of 1/a. So whatever the reciprocal of this number is. So it doesn't get stretched by 2, it gets compressed by 1/2. If a is something that's bigger than 1, the absolute value of a is bigger than 1. And then it's stretched by the same factor, 1/a, if the absolute value of a is less than 1. And then finally, if a is less than 0 or a is negative, it's flipped over the x-axis. So the stretching factor or compressing factor is the same. It's always 1/a here in horizontal stretches and compresses. The only thing, or compressions, the only thing that changes is the word we use to describe it, whether it's being stretched or compressed. So what you really need to remember is this 1/a is the factor that we're using. All right, going on. So let's go through this first one together, even though it's a you try, and then you try the second one. So on the first one, we are given f of x right here. It's this absolute value function, and we're going to try to graph f of 3x. So the first thing we want to do whenever we're trying to graph a new function from a picture here is to get some key points. So there I went ahead and I got some key points. Now, it may be hard. I know on the print-offs, it was a little hard to see the function. Hopefully you're able to see it up here. So I labeled these as my key points. They show me the shape of the graph. And now I'm going to write my key points down. So I've got my key points down. And now the 3 times x, what that does is it compresses horizontally by a factor of 1/3. So the reciprocal of 3. So with each of these points, I need to compress them horizontally by a factor of 1/3. So what do? I take each of the x values and multiply them by 1/3 to get the new position of the point. So I take -3 times 1/3 to get -1. I take -2 times 1/3 to get -2/3, so on and so forth. And then on my graph, I plot my new points. So there's all of my new points plotted. And then finally, I go ahead and I connect them to get my new graph. So this makes a lot of sense. Look, the red function is our original. The blue function here is that function if we horizontally compress everything by a factor of 1/3. All right, so you should go ahead and pause now and try the second one on your own. See if you can follow the same steps. The starting graph is the exact same starting graph here, only now we're doing f of 1/2 x. So start with the starting graph, follow the same steps, and see if you can come up with the graph of f of 1/2 x. When you unpause the video, I'll go through the answers. Okay, here we go. So we list the points again, exactly the same. Key points I started with. The red graph is the original here. Those are my key points on it. And then I stretch horizontally by 2, because the reciprocal of 1/2 is 2. So I take each of the x coordinates, so like -3, multiplied by 2 to get -6. -2, multiplied by 2 to get -4. So on and so forth. This 4 and 6 should be in green to show you that they changed. And then up here, I've just drawn some arrows here so you can see how the points moved from the original to the new function when we stretch them horizontally by a factor of 2. All right, let's go on. Now, we've got some different shape graphs here where they're a little more interesting. Same exact thing, though. Same exact thing. First, we need to choose some key points. So as I've talked about in a few videos before, we want to choose key points at any corners or any turning points. So there's my key points on the first one. Now I want to apply the shift. So I look up here, I'm trying to do f of 2x. So that means I'm going to stretch compress everything horizontally by a factor of 1/2. So I take each of my points and I compress them horizontally by a factor of 1/2. If you want to write out the coordinates, you are more than welcome to do that, but you might be starting to see exactly what happens here on the graph. So that's where my new points end at if I compress them horizontally by 1/2. Now I go ahead and I need to connect the points in a way that preserves the original shape of the function. So I connect them as such, and that right there is the graph of f of 2x in red. Okay, down here on the bottom, now I accidentally typed in an extra equal sign, the one right behind my cursor right now, right there. In the parentheses, that shouldn't be there. Now, once again, I choose key points. Oh, I don't even need to show that. So I choose the same key points. Now I look at what's going to happen. It's -1/2 x. So the 1/2 means we're going to stretch horizontally by a factor of 2, and the negative means flip over the y-axis. So I take each of my key points, I stretch it by a factor of 2 horizontally, and I flip it over the y-axis. So there's where my key points end up at. Now those points that started over here on this little parabola shape, they got stretched, so they were farther away, but then flipped all the way over here. So that's where those 3 points ended up. This corner right here below my mouse, that one got stretched and then flipped, so it ended up way over here. Now I just go ahead and connect my points in a way that remains faithful to my original shape, and I get my new function. So that right there is f of -1/2 x. Okay, going on. So you're going to need to make some adjustments to the table here. So first of all, cross off the function that's in there and rewrite this one. Basically, all you need to do is make sure the 1/2 x is all in parentheses, all being squared. So I've given you some x values here that I want to plug in. So go ahead and plug in those x values. Now, all we're doing right here is trying to get the graph of f of x. And in order to do that, all I want you to do is plug in the x values, get some y values or some f of x values, and plot those points. All you're doing is plotting points. Nothing about shifting or stretching or compressing. Just plug in x values, get some output values, plot the points, and draw the function over on the graph. All right, go ahead and pause the video and try that right now, and then come back and see if your graph matches mine. Okay, so I plugged those x values into the function. Here are the outputs I got. So -4, when I plug it in, I do 1/2 times -4, so that's -2, and then square it, and I get 4. So that's how I went about getting all of these y values. And then I plotted those points. You can see them on my graph here, and I connected them to get this graph. Okay, we don't have anything else we can do, nothing to compare it to yet. So let's go ahead and do the same thing with this function. So if I want to get some output values here, look, I've got a function. All I'm going to do is take the x values and plug them in. So in this first box right here, I'm going to plug -4 in for x and just solve for the output value. So go ahead and plug in all the x values to fill in this column for our second graph, and then plot those points in the graph that you have, and go ahead and connect them to see what new shape we get. Pause it now, and when we come back, we'll discuss it. Okay, there's my point. So I plugged in -4 into this function. So it was 1/2 times -4, which is -2, and then +2, which is 0, and 0 squared gave me 0. That's how I got that output. I'll go through one more together with you. Plugged in -2 here because that's the x value. -2 into this. 1/2 times -2 is -1, +2, +1. Square it. That's how I got 1. And I did that to get all of these output values. Now, this might have only given you half of this parabola, but since you know it's a parabola, you can go ahead and connect it to get the rest of it. Now, this is where the real important conclusions come in. This is where the big comparisons come in. So look at the function in black here, the first function. That's the one over here graphed in black. 1/2 x quantity squared. Look at the function that I did the points in red. It's graphed over here in red. What are the differences in these two functions? The only difference is that this one has a +2 inside the parentheses, inside the squared there. So we've done that already. We've done adding numbers in there, and we know what sort of shift to expect. A +2 in there should give us a horizontal shift. Should give us a horizontal shift to the left by 2 units. Look over here on our graph. Is this black graph, to get to the red graph, did I take everything and shift it to the left 2 units? No, I didn't. Look at the vertex right here. The bottom point is at the origin. It shifted over 4 units. Everything on the black graph, this point right here on the black graph, shifted over here 4 units. Everything on the graph shifted over 4 units to the left. So what went wrong? We're going to need to fill in the last row or column in this table in order to figure out. So we need to make another change here. I want you to go ahead and change the last function to what I have right here. Instead of x plus 4 in parentheses, I want x plus 2 in parentheses. And then go ahead and fill in the column in your table here, the blue numbers. Best if you do it without looking at mine to just get the answers. What you should do is take the x values in the chart, plug them into the equation, and go ahead and fill and then plot your points in order to get your new graph. So pause now if you want to do that on your own, and then check yours against mine. Okay, so here's the values I got. I'll go through one with you. So -4, when I plug it in here, I do the -4 plus 2 first, which gives me -2. And then I do times 1/2, which gives me -1. And then I square it, which gives me +1. So then that gives me the point -4, 1. So to graph that on my graph, I go over to -4, up 1, and I've got a point on my blue graph right here. So I go through and do that with all of the different x values in order to graph this final function. Now, compare this function f of x here to the original function. So that's compare the blue function to the black function. To get from the black one to the blue one, what did we do? Look over here on the graph. To get from the black one to the blue one, everything is just shifted left 2 units. This worked. We got the shift left 2 units this time. The red function, it didn't work. Just doing the +2 there in the parentheses did not shift the thing left 2 units. We had to do the +2 just with the x value and then apply whatever horizontal stretch we have. So this is a very important point right here. We're going to write some conclusions down at the bottom. Let me get rid of it. Oh no. Oh no. I lost where we're at. I'll get it back, guys. Don't worry. Don't despair. I know you're despairing, but you shouldn't. All right, there we are. So we're going to write down these conclusions here at bottom. So when we're looking at the different, I'm going to even change this from shifts to transformations, because we're talking both about shifting and about stretching. So when we're looking at different transformations on a function, we have to factor out a coefficient on the x if there is one before we do any horizontal stretches or shifts. So if we're analyzing different transformations, we got to factor out a coefficient on the x if there's both a stretch and a shift left or right. So for instance, and I'm going to get up here so I can write. So I may be a little quieter, but I hope you can hear. So in this function here in the middle, what I'm saying is we need to factor this 1/2 out so that this new function becomes f of x equals, I'll pull the 1/2 out of both terms. And what I mean by that, the best way to think of it is undistribute a 1/2 from each term. So pull a 1/2 away from the x plus undistribute a 1/2 to that second term. So that's going to be a 4 now. Because now think about it. If I distributed the 1/2 back in here, I would get a 2. I would distribute the 1/2 to an x and get 1/2 x, like is right there. I would distribute the 1/2 to the 4 and get the 2 that is right there. So this function in red is the exact same as the one we graphed up here in red. And right here, we can see the +4. And that's why our function, when we graphed it, the red one, it moved left 4 units. So we got to be real careful with how we write the function when we're looking both at horizontal stretching and horizontal shifting. Okay, let's put it all together here. So these are the steps that we need to follow. Forget the stuff earlier about following order of operations. It doesn't matter anymore. Horizontal stretching and horizontal compressing kind of throws that all out of the window. So these are the important steps. If I have this graph over here, f of x, and I want to graph this function right here, I need to first check to see if the inside needs rewritten. And what I mean is what we just talked about. Is there a horizontal stretch and shift and a horizontal, or is there a horizontal stretch or compress and a horizontal shift left or right? The 2 tells me that there's going to be a compression. The +4 tells me there's going to be a shift. So yes, I need to rewrite the inside by factoring a 2 out of both things. So I need to rewrite it like this. So the 2 times f of stays the same, but this inside right here, this is the only part that's different. Put it in bold right there. All I've changed is instead of writing it as 2x plus 4, I'm going to rewrite the inside to make it make more sense. Or to make it show me the transformations. Maybe I should make this a smaller font so that it makes it look better. Let's see if that works. Oh, that kind of works. So I've rewritten just the inside. Next thing we have to do is to apply any stretching and compressing, horizontal and vertical. So we need to look at our rewritten function and see what sort of stretches we're going to have. So this 2 right here on the inside gives me a horizontal compression by 1/2. This 2 multiplied on the outside gives me a vertical stretch by 2. Remember, the vertical stuff, straightforward. Multiplying it by 2 means stretch it by a factor of 2. The horizontal stuff, backwards. Multiplying by 2 means compress by 1/2. So I apply those to my function by taking some key points on my function and applying both the compression and the stretch. It doesn't matter what order you go in. Either way, if you pick your key points and apply the horizontal compression by 1/2 and the vertical stretch by 2, you'll get to this function right here in red. Now the next thing is to move left, right, up, or down, so any shifting as needed. So we look right here and look for any shifts. Do we have a horizontal shift left or right? Well, that's when we add or subtract something from the x. So yes, this +2 means we're going to be shifting left 2, because remember, all the horizontal stuff is backwards. So plus 2 means left 2. And then do we have any vertical shifts? Yes, the plus 1 means up 1. So we go ahead and move the whole thing left 2 and up 1 unit. And then in blue, that is our final graph of this function, 2f of 2x plus 4 plus 1. All right, I hope you found this video helpful. If you have any questions, please ask me during class. Have a good rest of your day.